Let's talk architecture. I've come down here to the lower part of the first gallery habitat where none of the internal structures have been built yet, just the shell of the building. Because the concept is that as people come to the settlement and the population increases, then slowly the internal structures are built as needed. So down here you can see the infrastructure much more clearly than you can up above. So first we can look at one of these gizmos. This is part of the thermal control system. These are heat pumps, and they're really big, and there's a lot of them because there's a lot of heat to pump away. You can't tell because of the way the lighting is done right now, but this whole volume is full of sunlight during the day that is brought in by a fiber optic and parabolic mirror system through the roof. That's a tremendous amount of heat that goes with that, and also all the other activities inside the space also create heat. So heat on the moon is an issue because surrounding your habitats is a vacuum, and vacuums are the best insulator there is. And on top of that, the roof is covered over by a very thick layer of soil to prevent radiation from coming in, and that soil acts as thermal mass, so what small amount of heat leaks out through that surface is trapped and mostly radiates back in because it's absorbed by the soil and stays close to the interior volume. There's so much heat to shed actually that you need multiple systems doing this all the time, because even if one fails, then another one can be doing the work, and you can't afford this activity to stop for more than maybe a few days. But you might as well take advantage of the fact that you have the ground underneath you that is minus 20 degrees Celsius, more or less, because that's a decent heat gradient, and you have anchors sunk deep into that volume anyhow, so you might as well make use of those anchors to pump away heat. Let me go into fly mode here. I try and not make this too dizzying. Sorry, we look like we're floating in space. This is actually under the habitat in the ground. And during construction, these boreholes were made, and cables go down through them, anchoring the structure to the ground. You would do that because the pressure of the atmosphere on the roof is so high that you need a system like this, making it absolutely stable no matter what happens, because you can't afford leaks. So since they're there, you might as well run coolant down that borehole as well and put it in contact with as much rock as you can. That's easier to do the farther down the slope of the crater you go, because there's more and more rock and less soil mixed in with it. And use the freezing temperatures down there to get rid of some of your heat. And once it's in that volume, maybe over time you can create supplementary systems to spread it out even more. At worst, you have a backup system that could give you a few days breathing space in case your other heat shedding systems fail. And at best, you have a thermal storage system so that you can make sure your interior volume stays at a nice, constant temperature, which is really valuable to creating a pleasant and abundant ecosystem. So a basic heat pump, the parts of the system are that you have this tube is the radiator surface. Inside the thickness of the walls is smaller tubes carrying coolant. There are fans inside the tube pulling air through it. And that also circulates the air, which is important because nothing else is making the air circulate. You have to do it mechanically and filter it at the same time. You can use that for both things. And then the coolant goes through these pipes to a pump inside this box and down into the anchors that I showed you down there. So notice how the blue boxes are located at the bases of these columns in the walls. That's because of the fact that those cables from the anchors are going up through there. So the anchor cables have to go through the roof and down the other side. And that's what is inside those columns. Each one of them contains powerful cables, redundant, so that if one of them breaks, the job is still done. Replaceable, because the columns are hollow. You can take one cable out and put another one in. See, we think about all these things, which is what you need to do if you want a realistic experience. Okay, that is our architecture on the moon lesson for today.